Evacuation of a VRF system needs more thought than a regular system. It's the details of this process that are going to dictate the success of this system over the long term. Step one of any good vacuum is a proper pressure test. I've done a video on pressure testing and leak searching these systems. I suggest you go check that out. But make sure that you've done a good pressure test, you've passed all the things, you haven't skipped any corners. Otherwise, you're wasting your time with the evacuation. You're just going to be chasing your tail, and you're going to end up having to go through all the pressure testing side of it anyway, because the likelihood everything in this system is perfect is slim. The next step in this process isn't necessarily the most obvious. Make sure the system is in evacuation mode. There is a mode in these systems that opens all of the valves throughout the entire system. That includes the indoors and the outdoors and the branch selectors or heat recovery units. This is going to go a long way in getting a really good vacuum to pull. Now, in addition to that, if you just finished doing your pressure testing like you should have, you would have put it into evacuation mode for that as well, get everything opened up. So you may already be in it, check. If there's any doubt that you're in that mode still, if it may have possibly come out of it, just put it back into it and just go through the steps and process. The service manual or the install manual is going to show you how to do that. It's a little different depending on the brand, but it's normally not that hard to do. Just a few buttons and you're there. I will do some videos on these types of things to give a more specific breakdown per type of equipment. Just be real quick, punch, hit this, go, you're done. So the next thing you're going to be thinking about is the pumps and the setup that you're going to use where you're going to hook up. Now, a lot of the time, you're not going to be in a situation where you need to or have access to multiple vacuum pumps, and that's okay. But in some circumstances, you may want to hook up, or you may have the availability to put a second pump on the system, and that's okay as far as I'm concerned. What you have to be careful of is the type of pump you choose and how you use it. The more traditional pump designs don't have any kind of backflow protection. So there's a rule in the industry that you don't hook up two pumps to the same system. And that rule comes from if one of those pumps fails or starts having an issue, specifically the oil, the vacuum pump oil, will backflow through the tubing into the system. And that does happen. And it is nasty, and you got to open it up and clear all that out. But if you use the correct pumps, or a pump that has backflow prevention, a TES 8 for example, the way that the chambers are designed in the outlet port, I've never had issues having a backflow problem out of those. And I've had 3 or 4 of those hooked up to a single system that we were having a lot of moisture issues and stuff. Like, it was a pretty extreme example. My point is though, I've been able to run that many pumps on a single system and not have any issues. That also includes, taking them down one at a time, cycling oils and doing all the stuff. Ultimately, the TES 8 by Appion is my pump of choice. Something to keep a lookout for. I've got tech sheets for these VRFs on the way if they're not already released. Be looking for those. Those will be on my website at hvactime.shop. The next core option to think about is where are we going to pull from, which this is one area where it kind of becomes different than traditional systems. Most of the time, the traditional system, there's only 1 or 2 choices to pull from to begin with. So it's a fairly simple option. In this case, we have multiple options, or you should if you did this correctly. So if the system's installed correctly, then it's going to have isolation valves. Those isolation valves should have pressure taps, and you're going to have that at the indoor units, isolating each one of those, or you're also going to have it at the branch selectors, which most of the time we're putting in some form of a heat recovery with a branch selector setup, and those themselves should also have ISO valves in addition to each of the indoors. What I have found works well for me is instead of hooking up at the outdoor, which you can absolutely hook up at the outdoor unit, I like to hook up in a more of a centralized or a middle point in the system. It doesn't have to be exact or perfect, but the reason I like that, and this is not what the manual says. The manual, if you read it through, they're going to tell you to hook up at the outdoor connections and just pull through the system that way. It's just a personal preference to hook up in the middle and let everything draw to that central point, because what you're having to do otherwise is if you hook up at the outdoor, The gases in the atmosphere have to travel a lot further through the piping network in order to get pulled out of the system as a whole. So for me, it has worked well to find a central point, hook up there. But the critical thing is your Micron gauge needs to go at the furthest possible place you can put it from wherever your pump is. Which this is also kind of another fundamental of regular vacuums. This isn't necessarily special. A practice I like using when I can is having a second gauge. What I did initially is I took my old busted gauge that I didn't really trust all that much, but it was kind of sort of accurate enough. Then I put that gauge at my pump. And its sole purpose wasn't to have necessarily an accurate reading, but it was going to be an indicator to me on how well the pump was still doing and what that pump oil was doing. Now, obviously the gauge still functions in some way, but when I see that gauge at the pump begin to equalize to my actual system gauge that I've got on the piping, or when I begin to see it stall out or start to rise at the pump, then that tells me that the pump itself, or more than likely the oil, needs to be changed. So having a gauge at the pump connected in whatever way you can, that's one thing great about the TES 8. It's got a 1/4-inch port right there at the pump, so it's real easy to hook up on its little manifold tree. You don't have to do it that way, just somewhere at the pump. You want to see what the pump's physical microns are, and having that as a comparison to the system microns will help you really understand, okay, I'm still either pulling at the pump, I just need to be patient, or hey, my pump is starting to stall out because I have an oil issue. On smaller systems, some of these things aren't near as great of an impact. You can get away with a lot more. When you start working on this large of a piping network, you're really going to appreciate having more data points, because you're likely going to have to be changing oil more often. You're going to have to watch it more closely. I'm going to say this part because not everybody I find practices this. I'm a firm believer in it. Put all your caps on and even throw a little Nylog on there. If you pressure tested and you made sure everything wasn't leaking, that's great. That also means that it wasn't leaking under positive pressure. That doesn't mean that it won't slightly leak under a vacuum. So as a means of just eliminating headaches for yourself, go ahead. You're confident it's not going to leak under pressure later. Put all your caps on. Get that piece of the equation out of the way. It's only going to improve your vacuum's depth and time. Now, if the system was purged with nitrogen during the install process, or if you were doing your pressure testing, the likelihood the system's probably fairly dry, or at least that's the hope. If that is true, then even on some of the larger piping networks, you're probably only going to have to go through 1, maybe 2 sets of oil, even with one single pump by itself. But that could be another indicator to tell you just how dirty the system is. When you start to pull, and if you're having to go through oil pretty consistently, and it's very likely that there are some kind of contaminants in there, or there was at some time. Now, if this was a burnout repair, this is going to take a lot more time. Just flat out, it's going to take it. Burnouts are very difficult to correct in these systems, and it takes a lot of work. I am a proponent for flushing. I know a lot of people aren't necessarily. It is a lot of additional steps. I've had some fantastic success with flushing these systems, but it has to be done a specific way. I'm going to do a whole video just on my opinions and what I've done to flush systems in the past. My point being, those kind of conditions are going to add a lot of time, even if you do it perfectly, to the total evacuation. And this is a huge reason why it's necessary that we get this vacuum process correct, because it's very common that these little things, just you cut too many corners and you end up having a systemic failure of the compressors and further burnouts and just more valve issues. It turns into this snowball. That's one reason why so many people have such a negative opinion of these systems. It's because little things, these little things don't get followed accurately or correctly, and that leads to just systematic failures you can basically predict. By the way, I'll mention real quick, I've started to get a lot of my manuals uploaded to the new website. Those are free to you. I'm not asking anything, not that I can, even if I wanted to, but I want to get that documentation, that information out there, whether it be some of the service manuals, IOMs. Go check it out. If there's some manuals in there that are going to help you or you could read or benefit, I think it's a huge way to help grow your own skills. Just read the IOM. Just read it like a book. I did that for many years. If I see something new that I want to learn about, that's the first thing I do. I go get the IOM for it and I start reading it. That tells you a tremendous amount of what this system is meant to do and how. Here's where we get to what's probably the most difficult part. These evacuations take many times several days. They could take a few hours. They could, and it happens. I've been able to complete an entire evacuation in less than a day on some smaller systems, even brand new installs. It normally takes days. And it's strictly down to the way the piping is laid out, how it's all stretched out. It's a lot of gases you have to move. Many times I have an easier time trying to get a chiller circuit with a large volume, but it's all in a fairly condensed place and it's all really large piping, so it's easy to move all those gases through the system. Where VRF, it's small piping stretched way the heck out, and it's not as easy. If you do start to see your system stall, it's worth doing a standing test. You know, don't get too aggressive. You got to be patient, and that's one thing with evacuations. You start tinkering with stuff, you'll create problems by accident. This is just one of those finicky things that you have to be patient, but you also have to just kind of live through it enough times to have confidence. Most evacuations stall out between about 1,000 to 1,500 microns. There's a vapor line in terms of the gas itself and atmosphere and such that you kind of run into, especially if you've got oil sitting in the system, or the ability for the system to flow those gases through or off gas out of the refrigerant oil. It basically equalizes with how much volume the pump can move at that point. So you hit this really weird spot, and this is like that 1,000 to 1,500 almost always takes the most time out of any other points in an entire evacuation, and it's perfectly normal. You'll find that once you kind of break below that 1,000 mark and you get down into the triple digits and below, it goes significantly faster, and you can get to 500 way faster than you can get from 1,500 to 1,000. So because of the possible outcomes, if you feel you need to do a standing test in that moment, then just isolate your pump, and the system microns shouldn't rise more than maybe about 100 within a couple of minutes. If you're rising faster than that, then it's very possible you've got a leak. And most of the time with moisture or oil in the system, once you start hitting between 2,000 to 3,000 microns, I've seen as much as 4 or 5 in some cases, but usually between 2 and 3, you'll really start to see that rise just come to a dead halt almost. If it stops or slows way down between the 2 and 3,000 mark, that is off-gassing of refrigerant, or if that is atmosphere in the system, it's not a leak. A leak, one, it'll have a faster curve on the micron rise rate. At the same time, it's not going to really stop. It's going to just keep trucking through. So when you do your standing tests, those are the specific things we're looking for. The more you see this data, the more comfortable you get with it, the faster you'll be able to identify it just by watching your gauges. It's also critical to just really learn your tools at that point and understand how they work, why they work. If the evacuation has stalled and you're very confident it's not a leak, whether that's through pressure testing or through the standing test itself, maybe it got up to 2,000 and then just halted, then it's probably worth your time to go ahead and do a purge with nitro. Break the vacuum, and what you'll get into is a multi-stage vacuum. Many times it's referred to as a triple evac. That just means that you did it 3 times and you went through 3 stages. It doesn't have to be limited to that. You can do it as much as you want. In some cases, I've been able to just break it once, and after that first time, it's able to pull down the rest of the way, and I don't have to go through all 3 stages. So anyway, my point, It's a multi-stage evacuation. One of the additional things that I like to do that I don't always see people recommend is when I brake, I like to purge for a few minutes. So I'll go into, say, like the suction line, and I'll just purge nitrogen, just a couple of psi, almost like you know, a brazing purge, but just sit there and let it flow through the system for a few minutes and let it cycle and circulate, and it'll help just continue to grab more and do more. On some systems where I've had a lot of issues, there's a lot of oil settling in the system, or the oil has just a tremendous amount of refrigerant stuck in it, things of that nature. I find that doing a purge for 5-10 minutes between starting each evacuation really helps draw a lot out of the system. Okay, so you've gone through all this process, all these little details, you've looked at this whole thing. Heck, you've been monitoring this system for 3 or 4 days, changing oil, going through the whole process maybe, and you finally hit 500 microns, or you say you dip below it, say you go 450, 400, something like that. You really get a great pull. Then you isolate and it doesn't really move that much. Fantastic. I have seen practices where all the technician is looking for is 20, 30 minutes, an hour, and then they want to call the evacuation good, start throwing charge in there and move on. And I'm not a huge fan of that even for regular systems, but I'm guilty of practicing it depending on the circumstances, especially for a small system. But by the time you get to this scale and you're working on a system like this and the intricacies of it, because it needs a fantastic evacuation in order to meet the efficiency demands and require there's a lot that goes into that refrigerant's ability to perform inside of that circuit and minimize contamination as a whole. Keep in mind, there's no filter dryers in this system, so you're not gonna be able to get away with, well, I'll get it almost perfect and let the filter dryers take care of the rest. So you've gone through all this standing test. If you're in a true emergency, you need to get this system online, you're in a hurry, the most I would ever allow is a 4-hour standing vacuum, and that is really rushing it. You need to give it that time, and basically what you're looking for is you just don't want to exceed 500 microns. Now for me, how I interpret that is 500 as a loose term. So essentially, as long as, you know, if I start at 450 and I end at 550, I'm comfortable, I'm okay, we're just gonna go ahead and move on. If you end up running above that, say into the 600-700s, then you really need to pause. Now there is a industry practice where you start the test at 500, and as long as you don't rise above 1,000 microns within your designated time frame, typically 12 to 24 hours, then you're good. The reason VRF are looked at differently is because you don't have the dryer. So it is beyond important that this evacuation be spot on. So don't use that. You really need to stick to, we should be able to satisfy 500 microns, and we should be so tight that we're able to hold that consistently. Now, if you're doing a factory commissioning, the factory's expectations is going to be 500 microns for 24 hours, period. You do not start putting refrigerant in, you don't do anything until it's able to hold that for 24 hours. And that is the best test. So if you've got the time, you're not in a critical situation, you really need to practice that 24 hours window as much as you can. I have a habit of sometimes only doing 12. You know, if I've got a system that I've trusted, I've worked on it in the past, I know the basic characteristics and the condition of this system, then maybe I'll go to the 12. But especially if it's a new system to me that I haven't worked on previously and I'm learning what kind of condition and how the install is, things of that nature, then I absolutely do the 24 hours to protect myself and the customer. So there you have it. You finish your test, you pass all the standards, you move on. You start adding refrigerant. That would be the next step. You add the refrigerant in by weight. I do plan to do a video on actually charging the system and how to hook up, and just my personal thoughts and process in the matter. And I also want to do something about how to calculate the charge. That's something that I find that very few people, even experienced people, aren't that comfortable with. It took me some time to really just get my head around it, and I still, like, even when I sit down and do it, I got to think about it, you know. And there's worksheets that the factory gives you for that. I plan to do some content on calculating those things. Now that's going to be more brand specific, so you can use what that brand says they want. So there'll be probably multiple of those. So these are my personal processes. These are my personal opinions. These are the things I've done for many years. I've experimented in a lot of different directions with this, and I've done several systems wrong and paid the prices for it. So my point here is try to see what I've said works for you and what you could take away to benefit your own process. Mine is not a one-size-fits-all, and things like climate and ambient temperatures affect evacuations and pressure tests. There's just a lot of variables to this. What I can tell you is if you don't pay attention and this isn't right, you're going to create conditions for compressor failures and burnouts. And for a system like this, when those conditions start, it's really hard to stop it. And the customers have a terrible experience. And it also very negatively impacts the performance and efficiency of the system. If you're in a spot and you're working on these systems or any kind of a chiller system, go check out my website and see if one of my tech sheets will help. Those are specifically designed to be quick reference sheets so that you can get in, you can look at the numbers you need, and we work on so many different systems that it's hard to remember every little parameter. So the tech sheet's purpose is so that you can quickly see, okay, these are my max and mins, if you will, or these are some just basic recommendations from myself and what the factory says the tolerances are on these different components. Those types of purchases go a long way in supporting what we're doing here and our ability to create this type of content, get it to you, get better education, and create more tech sheets. Like we're gonna build a whole library of these things. With that, MTT, take care of your family, take care of your spouse, spend time with your kids. I'll see you around, guys.